Welcome to this episode of the Geotechnical Engineering Podcast. In this episode, I am talking with Kirsten Grant, Project Engineer at Schnabel Engineering, about the challenges and intricacies of bottom-up retaining wall construction and the emerging trends and technologies shaping the future of geotechnical engineering. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast. But before we get started, we're going to hear a word from today's sponsor, that being PPI, a Kaplan company.
PPI provides expert prep courses and study resources designed to help you pass the FE and PE exams the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. Check out PPI today at ppi2pass.com to see all the options available for FE and PE exam prep. Now let's dive into today's episode.
All right, Kirsten, thank you for coming on. How are you doing?
I'm doing well. How are you?
I'm good. Well, it'd be great if you could set the stage for us by telling us a little bit more about yourself and also what inspired you to pursue a career at geotechnical engineering.
Yeah. Well, first, thank you for having me on this podcast. It's an honor, and I'm excited to talk about what I do and, just have a good conversation today. Thought I wanted to be an architect, found out I wanted to do a little bit more math and STEM related. I love math and science to a certain extent, but really math. So then I went and actually decided to get my civil engineering bachelor's degree at Wentworth Institute of Technology in Boston. So it's a small engineering and design school. If you're not really from the Boston area, many people haven't really heard of it. But there is where my love for geotechnical engineering stemmed. So I had Professor James Lambrex, who worked for Haley and Aldrich, worked on the Big Dig, and is a pretty well-known geotech up in that area. So he inspired me, told me that I could go to whatever school I wanted to, and so I applied to a couple different top engineering programs, and I decided to go to Virginia Tech. So I got my master's in civil engineering with a geotech focus there. I met my husband there too. So fun fact, he's also a geotech.
Okay.
Yeah. And so from there, I wanted to do geotech. I threw all my structural books away. I was like, I'm done with structural, geotech's the route. That was not my strength in undergrad. And then just the way the cookie crumbles, I was looking for an internship, and I met Alan Cadden at, the Geo Institute and Structural Engineering Institute Geo Congress in 2016, and got an internship and got a job and ended up doing Geostructural. So I do probably 50% structural now. So yeah, but that's a little bit about me and my background. I primarily do retaining walls, supportive excavations, some foundation design, and then pretty much anything else that comes our way. That's kind of that mix between geotech and structural, and I do a little bit of pure geotech as well.
Oh, that's great. I love that what you said you weren't going to do, you ended up doing, right?
Yeah. It's a wild ride. Nothing ever turns out the way you think it's going to turn out, right?
Yeah, no, you're right. That's why we buckle the seatbelt in the morning, right?
Yeah, exactly.
All right, that's awesome. So Kirsten, for our listeners who might not be too familiar with the concept of bottom-up retaining wall construction, can you talk to us a little bit about that? And also, what are some of the common challenges that engineers face with this approach?
Yeah, so when you think of a bottom-up wall, a lot of people think of MSE walls, mechanically stabilized earth walls, or something along those lines. And that definitely is a good solution for a lot of areas. But where there are issues that an MSE wall can't handle or other reinforced earth can't handle, like global stability issues, limited area, or if the geologic conditions don't allow for the use of an MSE wall, a bottom-up retaining wall in a more traditional sense of retaining wall, like soldier pile and lagging, is a good option. It's difficult, but it can be done, and we've done a couple. It's probably my favorite type of wall to do. A lot of challenges. So some of the challenges that we face are installing the piles and the tiebacks themselves and considering that in design. So instead of doing the typical excavation, top down, where you can install the tiebacks, and you're going to increase load, throughout your, I guess, installation, the way that traditionally things have been researched and designed. You really have to look at, for the bottom-up wall construction, all right, how are you going to install these tiebacks? Can you install them from the front of the wall? If you can't reach, are you going to install them from behind and grab and install them, kind of reach around the piles, or do something like extend them from the base of the wall and install the tiebacks into the bench of the wall, all that kind of stuff. So means and methods are huge for contractors considering construction surcharging and how's that going to influence the tieback. You want to make sure you lock the tieback off low if you're installing it at the bottom of the wall so that you don't overload it and overstress it in the long term. And then settlement is a huge issue. So top-down walls, you don't really have to worry about settlement as much typically, but this, you're putting backfill behind the wall, and what's that going to do to your tiebacks and your piles and everything else behind it? So lots of challenges there.
Excellent. So from a bottom-up wall, what's an example of why we would do this?
So an example, one of our bottom-up walls that we did was in an area where there was slick-and-sided red bed material. So the global stability, there was a deep-seated failure zone that was at the rock-to-soil interface. And if you put an MSE wall out there, there was historic instabilities. So you're just going to have an issue with failure long-term out there. So the soldier pile and the tiebacks were designed to withstand the movement of that, I guess, the instability and the global stability of the structure. So the piles and tiebacks were designed to stabilize that failure and limit that. So the retaining wall there, it wasn't designed as much for the actual retaining wall itself. It was a heavy retaining wall because of that landslide stability.
Got it. Thank you for that. And how important is it to include flexibility in the design of retaining walls and other geostructural projects?
It's huge. As I'm sure you know, things hardly ever go as planned. There's never a project where probably never say never, but hardly ever do you go through a project where you're not having an issue with things coming up that you weren't foreseeing, like different soil conditions. We had a project, it was supportive excavation, and we had a decent amount of borings, and, but the nature of what we do is we typically don't have a lot of data that we want. We usually get the geotech report and have to design with that. And also you're getting such a small area of the data that we had this pocket of white. We said it was a disintegrated whale. Who knows what it was. This white rock that was not in any of the borings, any of the subsurface investigations, and it just failed a bunch of these were rock anchors. But, so you have to redesign for that. Changes in alignment, the project shifting, that's all huge in making sure that you can make your retaining wall work down the road when you're actually in construction with all these things changing. So we build some sort of resiliency into a lot of our projects to just make sure that we can keep things going smoothly. And when there's an issue and the contractor calls us up, we're not panicking and saying, we didn't think about that. We think of, okay, how can we move forward and make this better and use what we've done to get a good product.
Got it. And how would you say that engineers can leverage their willingness to put in the effort and try new things especially when they start out new in a career? What are your thoughts there?
Yeah. So I think that's the biggest thing. The willingness to do whatever you get thrown your way is huge. So I've been asked, I do a lot of the recruiting for our office here in Chadds Ford in the Geostructural group. And I've been asked, what's the thing we're looking for the most? And I say willingness to learn. I want people that are intelligent and, that can answer questions. But if you're not willing to learn, try new things, and go out in the field, spend a couple of weeks there, get out of your comfort zone, be away, you're not going to really gain as much. The people that I see succeeding the most are the ones who are willing to put that extra effort in and even just do the stuff that other people don't want to do. You can't grow if you're not getting out of your comfort zone.
That's so true. And it seems that, when you come outside of your comfort zone, you may actually love what it is you experience. And it's like you could have completely missed out on that opportunity. So definitely support that. Support that. And what's your experience been with field work and How does that impact your engineering practice? And how has that helped you to become a better engineer? Assuming it has.
Yeah. No, I agree. I think that, yeah, it has definitely helped me become a good engineer. And I think the people that have spent the most time in the field usually are the strongest engineers. So first, just understanding the soil. You're out there, you're feeling it, and you're seeing how it's acting. You're not just looking at a textbook and looking at drawings and saying, okay, this will work. You actually get to go out there and see what's being built, see what works, see what doesn't. You might have this awesome plan on your drawings and this is going to work, this is it. But if you don't have that constructability in your skill set, the contractors are going to look at it sometimes and say, how am I supposed to actually build this? In theory, it's great, but how are you going to actually install this in the ground? And yeah, I think that's huge. And then also the soft skills that you learn when you're dealing with contractors. So communication, if you can't communicate it to the contractor, then how are you supposed to communicate it to your staff as you continue to grow? Working with the contractors and being able to, relay what's going on in your head into them, that they might not have the technical background, but they have other background that they know what's going on just as well as you do. And you guys can solve problems together. And if you relay the information and work together, you can get a lot of stuff done.
Excellent. Now you said that you're responsible for a lot of the hiring or interviewing, right? So I assume that you're interacting with students quite a bit. So, how can we better inform students and early career engineers about the wide range of specializations and career paths in geotechnical engineering? And what advice would you give them in order to find their niche in the field?
Yeah. So like I mentioned before, I never thought that I didn't know geostructural was a thing. I never thought I'd want to go in that path. So I'm really grateful that I had the opportunity to try something new. So us as professionals, I think talking to students, and I myself need to get better at this too, but getting involved, having those conversations with students, sharing what you're doing these podcasts. I mean, this is huge. This is a great opportunity. All the podcasts that are out there, including this one, to have the students listen and see what other people are doing. When you're in school, and I was talking to my friend Will Schaefer, we just missed each other in grad school, but he's now at UC Irvine, and I saw him at IFC, and we were talking, and we both kind of did more the geostructural route, and we were talking about our colleagues that we went to school with and how everyone does something different. And it's good to know now that we have a list, but when we were in school, we all thought, this is geotech is it seems more narrow than when you're actually in the field and you can go into construction, all the different opportunities. Some people don't even do engineering after they get out, but which is good, and it's good to have a background. So I think, as professionals, going to talk at universities, taking on interns, working with those interns and giving them different experiences in your company. So we have 3 business units that we have, geotech, we have dams, and we have tunnels, and each of them have people that do geotech in them, just different ways. And having people exposed to all that as an intern or staff and seeing all the different things, getting opportunities to work across those lines will allow those students to get that experience. And then the students, seek out people, look up different podcasts and videos, and take on as many internships as you can. And when I was an intern, one of my first internships, someone said, try internships at every different type of civil engineering and every different type of office, because you don't know what you might not know exactly what you like, but you'll know what you don't like. And that's
so
true.
So true.
Yeah. So.
Yeah, whether you want to be at a big firm or a small firm, private or public, agency, consulting, academic, there's so many different things you could do, but you're right. It's easy to know what you don't want to do.
Yep. Yeah.
So that could be just as valuable as thinking you know what it is you want to do. So.
Yeah.
So collaboration's super important in engineering. How do you see different types of geotechnical engineers working together on large projects?
Yeah. So this is huge. We work as a geostructural, we come in usually after the geotech has been done. So the subsurface investigation has been done. So we rely heavily on those reports and those geotech engineers to help us understand what was actually at this site. Usually, every once in a while we'll have one that's an internal Schnabel where we can actually, work closely and together with those people. But usually we have to call them up if we have questions on the geotech or use their data. And then just collaborating, with the local. So we do a lot of work throughout the country. So collaborating with local geotechs who know the area in and out and help us to understand what are the things that we may miss. What do we really need to know? So that's huge. And then just overall, whether it's doing foundations and how that interacts with the structure, or, like rock slope stabilization, people have their own niches. And if you can work together, you can understand what the differences are in, or lack of knowledge that you might have, and work with people so that they can give you more knowledge and a better product, and, work together as a group to get the best solution out.
Okay. And before we take our break, what's the final piece of advice that you want to give engineers that are looking to make a significant impact in their careers as it relates to the field of geotechnical engineering?
So kind of already touched on this, but what I would say is take on as many challenges as you can, especially earlier in your career. So, anything that comes your way, say yes. There's some stuff that I did that was not related to what I do at all, like geophysics, going out there, attempting to swing a sledgehammer. I don't have that strength. But I learned so much more about what geophysics does, or, which we have in-house. But just say yes to everything. Don't sit there and say, that's not in my wheelhouse. That's not what I do. So I'm going to pass. By gaining as much knowledge as you can, you're going to get as many opportunities handed to you as people can give you. And that's going to just expand your ability. And then getting to know your colleagues well, know what they do, know who they are. I think then you can pick up the phone, call people, and be able to get the help you need, or be able to help them, and do some internal business development, and then get involved with as many professional societies and internal trainings and opportunities as you can.
It's great. I hope folks are taking notes. You just gave the cheat codes there. That's awesome. All right, we're going to take a break, and then we're going to come back in just a minute and close this one out with Kirsten in our Career Factor Safety In segment. Stick around. All right, welcome back. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Kirsten Grant, PE, from Schnabel Engineering. So, Kirsten, you've had a very successful career thus far. And when you look back on your career, what's something that you've implemented into your career to give yourself, let's call it a factor of safety in your career?
Yeah, so I would say something that I implemented was I diversified my skills beyond just technical. So I do a lot of personnel management. I supervise 2 people, and I've always kind of been in the inner workings of the Geostructural group here at Schnabel. So I think that has helped me really diversify and add a factor of safety into my career. It gives me a unique skill set that others may not have, and I can do more of a utility knife with that. And it gives me different opportunities, like the ability to do business development, write papers and present, do stuff like this that I wouldn't necessarily have if not.
Excellent. It's great. Well, thank you so much for coming on and for sharing all the great insights with us. You shared some information and advice I know is going to be helpful for those that are listening and those that are watching. If somebody wanted to reach out to you, get more information, what's the best way for them to find you? You're on social media, or you have an email you want to share? We can put it in the show notes.
Yeah, I'm on LinkedIn, so people can definitely reach out to me via LinkedIn Messenger. My email is kgrant@schnabel-eng.com. People, feel free to ask any questions, or if you have anything that you want to talk about. And thank you so much for having me, Jared. This has been a great opportunity.
Thanks, Don. This is great. Thank you so much for coming on.
Thanks.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary are the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the very best in all of your geotechnical engineering endeavors. Peace.